So what we have here is my lovely Tektronix 453 oscilloscope. For those of you who like a little bit of history behind things, this was one of Tektronix's very first all-transistorized non-vacuum tube oscilloscope back in a long time ago. That's not actually entirely true. This oscilloscope does have two new Vistors on the front end of it, from what I understand. But in a shameless plug, I hope that you guys award me the new oscilloscope so I can replace this this boat anchor. I'm ready to take it fishing. So what we have here, the top trace, is the charging of the coil on the metal detector. This is a pulse induction technology metal detector. So we set up a magnetic field within the coil, and then we suddenly cut it off and we listen for the eddy currents being rebroadcast by the excited metal objects that would be within the coil's field of view. On the second line, we have the decay curve of the coil. Now, this is a standard pi construction of a pulse induction metal detector. So what we'll see is we'll see the front end has some diode limiting or some voltage limiting diodes to squelch the flyback current, which is in excess of 400 volts on this. So what I will do now is I will take a very large metallic object, just for demonstration purposes, and I will pass it back and forth over the coil of the metal detector. Now, with that being said, you can watch the curve change, and I'm going back and forth. And here I'm in the coil, you see it flatten out, and then it's back out again. So here the metal object is within the coil and back out again. So when you're looking for things with metal detector, while a big utility knife may be a little exaggerated, we can do this. It looks like that. So you can have your favorite analog circuit or digital circuit process that information and determine if you have a metal object in there or not. So that is the cool thing that I can measure with my Tektronix 453 oscilloscope.